This lesson is about the angles inside of various polygons. Starting with a triangle, you may or may not know that if I have any triangle, the sum of the angles inside of this triangle will always be the same thing. Do you know what that is? Of course you do. The total degrees of the three angles inside of a triangle will always be 180 degrees. Alright, so a triangle has 180 degrees. What about a quadrilateral of any type? It doesn't have to be a parallelogram like this. It could be any random quadrilateral. But how many degrees if I added up, all of these angles? Okay. Do you know how many degrees this would be? Alright, if you have it memorized, that turns out that is 360 degrees. Now, if you have both of these memorized, you're already ahead of the game. A lot of people only know the one about the triangle. But there are circumstances in which we need to know what the degrees are for even more complicated shapes. Like, what about a pentagon? Or what about a hexagon? And so on. Alright, so it turns out that there is a formula for finding the total degrees in any shape. If we let n be the number of sides, okay, if n is the number of sides, then the total degrees can be found by the formula n minus 2 times 180. So for a triangle, if we use that formula, n minus 2 times 180, well, the number of sides is 3. Okay, this has 3 sides, obviously, so n is 3. So that would make this 3 minus 2 times 180. Well, that's just 1 times 180, so it makes sense I'm going to get 180. If I do this for a quadrilateral, a four-sided shape, then this has 4 sides, so that this becomes 4 minus 2 times 180, which is just 2 times 180, which is 360. Alright, if I have a pentagon, here n is equal to 5. So if I do n minus 2 times 180, that's 5 minus 2 times 180. Alright, I'm going to use my calculator to help me out, but I could just do 5 minus 2, or I could have just said 3, times 180. Okay, so a pentagon has a total of 540 degrees. Who knew? And one more time, let's do this for a hexagon. For a hexagon, n is equal to 6. So this would be 6 minus 2 times 180. So that's 720. Okay, so a hexagon has 720 degrees. So I needed you to have that formula back in the front of your mind. Alright, so if I could give you any shape, and you should be able to tell me the total degrees of the interior, the inside angles. And in general, once we get up above about 12 sides or so, I start just saying the number and then the word gon. Okay, so a 24gon would be a 24-sided figure, which I don't have a diagram for, but you can imagine it. If I wanted to know the total degrees, for a 24gon, I would do 24 minus 2 times 180. and that would give me the total degrees of a 24gon. Well, I'm just going to go ahead and do it since I started it. I always finish what I start. So 24 minus 2 times 180. So that's 3,960 degrees. Okay, so there's that. Now, by the way, sometimes I want to know about like an equilateral shape. All right, a shape that has all the sides are the same. So imagine that this triangle is an equilateral triangle. If I want to know the degrees of each angle, all right, let's do this in purple. How would I find the number of degrees of each of these angles if they're all the same? All right, well, hopefully you can see I would just do 180 divided by 3. So that would tell me that this is 60, 60, and 60. So what did I do? I took the total degrees, and I divided by the number of sides. All right, that's how I find each individual angle. All right, this is not really going to work for, this would not be an equilateral quadrilateral. For that, I need a square. All right, a square would be equilateral. So let's do that. Okay, so here's a quadrilateral with equal sides and equal angles. Now this is common sense what these are, but just to follow the pattern, again, if I wanted to know the measure of each angle, I could just take the total and divide by the number of sides. The total degrees divided by the number of sides. So if I took my 360 and divided by 4, that's going to tell me that each angle is 90 degrees. So it's almost like a formula that I want you to know. Anytime I want to know one angle or each angle, all right, each angle, you can always find that by taking the total degrees and dividing it by the number of sides. Okay, and just to be clear, the total degrees, we have a formula for that now. So if I need it, I could write down the formula. All right, total degrees, well, that's n minus 2 times 180. The number of sides, well, that's n. So basically, this acts like a formula for finding one angle, assuming that all the angles are the same. Okay? But I hope you see it's common sense. I don't want you to sit here and try to memorize, okay, n minus 2 times 180 divided by n. I want you just to go, oh yeah, well, of course. You know, this is back to like the 3rd grade. If I have the total and I want to share it equally among my friends, I'm going to divide by how many friends I have. So if my total degrees is 540 and there are 5 angles, of course I'm going to do 540 divided by 5. Let's see, 540 divided by 5, that's 108. So for example, each one of these, whoops, I left out the 0. Each of these angles would be 108 degrees all the way around. So let's follow through and do that for the hexagon here. If I wanted to find one angle of this hexagon, I would do the total divided by the number of sides. And that's 120. Okay, so each one of these angles would be 120 degrees. The total divided by the number of sides, that's how you get one angle or each angle. All right, store that in your brain as we look at the exercises. Okay, that was the old assignment. All right, so here's our first exercise. Find the sum of the measures of the interior angles of the indicated polygon. Heptagon. What in the world? Okay, so you definitely need to know the names of all the first several polygons. Obviously, a triangle is 3 sides, but if it has 4 sides, that is a quadrilateral. You can see the word quad in there. Most of you know that. I start to lose some of you on these next few. A 5-sided shape is called a pentagon. Pentagon. A 6-sided shape is a hexagon. Hexagon. And a 7-sided shape is a heptagon. Heptagon. An 8-sided shape is an octagon. Most of you know octagon, maybe because of things like octopus. And you know octopus has 8 arms. Okay. A 9-sided shape is called a nonagon. A 10-sided shape is called a decagon. I'm hoping you can be familiar with deca. Have you heard of a decade? A decade is 10 years of time, and 10 sides is a decagon, so the prefix deca means 10, so maybe that will help you. And then finally, a dodecagon is a 12-sided shape. So you need to memorize those words, that vocabulary, okay? So, getting back to the lesson now. So, heptagon. How many sides is that? Alright, hopefully you remember that heptagon is the 7-sided one. So if I want to find the total degrees, of course I'm doing my n minus 2 times 180. So I'm just doing 7 minus 2 times 180. Okay, so that is 900. Okay, 900 degrees. 32gon, it would be a 32-sided shape, right? That just means n is 32. So when I do my n minus 2 times 180, I'm just doing 32 minus 2 times 180. That is 5,400. I guess I'll put it over here. Okay, pretty simple. Now, number 10. We are supposed to find the value of x. When you're trying to find the value of some variable, it's usually a matter of finding a way to write an equation that you can then solve for x. For a problem like this, there's sort of an easy way to write the equation. Because of what we just talked about with the whole n minus 2 times 180 thing, we know how to find the total degrees of any shape. So for example, I should be able to find the total degrees of these interior angles. So let's do that. If I do a quick, I don't know why I put a 9 there, but if I do an n minus 2 times 180, in this case we've got ourselves 1, 2, 3, 4, 5, 6, 7 sides. Okay, so that would be 7 minus 2 times 180, alright, which we just did up here, so we know it is 900. Okay, so the total degrees in this heptagon is 900 degrees. So I could put that on one side of the equation, knowing that everything inside of here, all of these angles, better add up to 900 degrees. So all I have to do is create an expression of the sum of all of these. This plus this plus that plus that plus this plus that plus this. If I add up all of those things, combine my like terms, that expression should equal 900. So that's what I'm going to do. Let's start with the like terms that have a variable in it, like 2x plus x. In fact, right now those are the only one with x's. So that makes 3x. Now, if I add up these constants, alright, 156 plus 133 plus 99 plus 112 plus 145, let's see what I get. I get 645. Alright, so that means that if I add up all these expressions, that makes 3x plus 645. And again, the total should be 900 degrees. Alright, the sum of all these angles should be 900 degrees. That's what that formula up there meant. So we made an equation that has x in it. We should be able to solve it. So how would we solve an equation like this? Let me get rid of some of this junk. Of course, I'm going to subtract 645 from both sides, like this. So minus 645 minus 645. Well, that's 255. So that's going to give me 3x equals 255. Continuing to solve this for x, it looks like it's time to divide both sides by 3. X equals, go back, 255 divided by 3. 85. So x is equal to 85. Okay, that is how you do that. Number 11 is very similar. Let's see, how many of these are exterior angles? You can tell by the way they are outside of the shape like this. There are 1, 2, 3, 4, 5 of them. This is a pentagon. Now, if I want to find the sum of the exterior angles, I do not do n minus 2 times 180. That is only for interior angles. Luckily for us, exterior angles are even simpler than that. Does anybody remember how we find the sum of all the exterior angles? Hopefully you remembered that it is always 360. There is no expression. It doesn't matter. It's always 360 degrees on the outside of any shape. So that's the total. Now again, on the left side, I work these expressions right here. If I add up all of the exterior angles, it should equal 360. Alright, that's what we're saying. So let's start again with the variables. So I've got x, and I've got 4x, and I've got another x. So that's 6x so far. Now the constants. Let's talk about the constants. The constants are 137 and 43 and positive 1 and negative 1. Of course, positive 1 and negative 1 just cancel each other out. But 137 plus 43, well, that turns out to be 190. So I've got 6x plus 190 is equal to 360. So it is time to subtract 190 from both sides. Okay, that is going to give me 6x equals 170. Time to divide by 6. And I get 28.3 approximately. So x is approximately 28.3. Alright, so I would have put that here, and this would have been 85. Okay, that is how you do number 11. So again, you set up equations. If they are interior angles, you use n minus 2 times 180 to find the total. If they are exterior angles, everything always adds up to 360. Regardless, you add up all the expressions, combining like terms, and you put that on the left side of the equation, and then you solve. That's how you find x. Let's see what's next. Find the measure of each interior angle. Each one. Didn't we just talk about this a minute ago? What did I just say? Oh yeah, we talked about how if we wanted to find each angle, or one angle, I always do the total degrees divided by the number of sides. 180 divided by 3. 540 divided by 5, and so on. Obviously, if I take the total degrees and share that equally, I'm going to get a single angle. So, but we can sort of work this as a formula, okay? Total degrees divided by the number of sides, that's how we get each angle, or one angle. Keep in mind that we find the total degrees by doing n minus 2 times 180, and the number of sides is like n. So this is sort of a formula for finding one angle, but I hope you don't feel like you have to memorize it. It should be common sense. Total degrees divided by number of sides. In fact, just to make it more obvious to your brains, maybe we'll do this in steps. First step, find the total. Okay, the total degrees. So that's going to be n minus 2 times 180. In this case, for a 55 gon, that's 55 minus 2 times 180. That looks like this. I get 9,540. Okay, so that's the total degrees, 9,540. Did I remember that right? Yes. Alright, so that's the total. Time for the next step. Second, divide by the number of sides. Why can I not spell divide? Divide by the number of sides. Okay, so that's going to be 9,540 divided by 55. So divided by 55. That's 173.5. Okay, I'll put that here. Okay, and that's degrees. Number 13, Decagon. Alright, please understand that Decagon has 10 sides. Alright, so it's going to be, let me do this slightly differently. If I'm going to find each interior angle, each angle should equal the total divided by the number of sides. And for the total, of course, I'm going to do n minus 2 times 180 divided by the number of sides. So this is a decagon, so this would be like 10 minus 2 times 180. Looks like this, 1,440. So that's the total. Okay, so this is going to equal 1,440 divided by the number of sides, which is 10. So that's going to be 144 degrees. Okay? If you want to find one angle, do the total degrees divided by the number of sides. Now, keep that in mind as we approach number 14. Again, we're supposed to find the measure of each interior angle. As soon as you see that we're finding one angle, you're going to set up our little formula. Okay, one angle is always going to equal the total divided by the number of sides. Okay, so in this case, we don't know the number of sides, so all I can do is write n minus 2 times 180 as an expression for the total. The number of sides, the expression for that is just n. But there's one thing I do know. This time we're being told that each angle is 150. So, in other words, one angle is 150. So this whole expression should equal one angle. This is the expression for one angle, so it should equal 150. So it's just a matter of solving this equation. Just to make it more clear, I'll just put a colon here. So we just need to solve this equation. How do we solve it? I'm going to show you two ways to do it. One way is algebraically. If I divide both sides by n, that way these n's cancel each other out. So that's going to leave me with n minus 2 times 180 is equal to 150n. Next, you really want to go ahead and do the distributive property with that 180. So this would be 180n minus 360 equals 150n. Next, I need to get these n terms together. So what I'm going to do is I'm going to go ahead and subtract 180n from both sides. Alright, minus 180n. Well, look, that's negative 30n. I'm going to bring this party up over in this area. So that's going to leave me with negative 360 equals negative 30n. Of course, I'm going to divide both sides by negative 30 now. Looks like this, and guess what? 12. That gives us that n is equal to 12. Please let us remember what n represents. N is the number of sides. That means based on the fact if each angle is 150, then this must be a dodecagon, a 12-sided shape. Alright, so I would just write that down, that n is 12. Okay, look, there is another way to do this. You can decide what you want to do. I'm going to use my TI-30 XS multi-view. If I know that each angle is equal to the total divided by the number of sides, which would be represented by this formula, n minus 2 times 180 over n, I can put that in my calculator. Try this with me. If I go to the table, okay, let's set up this fraction. So let's do our n, we'll have to use x, but you know what I mean, n minus 2 times 180 over n. And again, I'm just going to put x because that's all I got. So this is a function that's going to give me, this is going to tell me what one angle would be depending on how many sides. You know, x here represents the number of sides, like n. So this should make a table of values. So it shouldn't, I'm getting a negative number for a single angle because you can't have a one-sided polygon or a two-sided polygon for that matter. The smallest polygon is 3 sides, so here we go. This is telling us that a 3-sided shape has 60-degree angles. 4-sided one has 90. A pentagon has 108 degrees. A hexagon has 120 degrees each angle. A heptagon has whatever this is. You know, I say whatever this is, but if I hit toggle, blam, it will turn that into a decimal for me. Remember that I'm looking for the number of sides that's going to, no, I'm up here. I'm looking for the number of sides that's going to lead to each angle being 150 degrees. And I'm getting closer and closer. I'm up to 128, 135, 140, 144. Better check it out. Toggle it. 147.2, getting closer. 150. So, a 12-sided shape, each angle is 150. Just to review, I got that by using this formula, because this formula is the total degrees divided by the number of sides. Either way, you're going to get n equals 12. Number 15 is actually a little bit easier because exterior angles. Remember that exterior angles always add up to 360. Okay, exterior angles total is always 360 degrees. Okay, so it's like this. The total divided by the number of sides should equal one angle. Okay, so keep that in your mind. So in this case, the total is always 360. Divide that by the number of sides. Well, it says find n. That means I don't know the number of sides. But that should equal one angle. Well, look, the measure of each exterior angle is 20 degrees. So they're telling us that one angle is 20 degrees. Alright, do you remember what we learned? When the unknown is in the denominator like this, what can I do? I can do the reversal. So this is going to become 360 over 20 is equal to n. Alright, so that's going to be 18. Alright, so there's number 15. Alright, 18 sides. Okay, this is the last one. List the angles in order from least to smallest to largest. Remember that the smallest side will always be across from the smallest angle. So 8 is the smallest side, so it will be across from the smallest angle. So I'm going to start by listing angle E. Then the biggest side should be across from the biggest angle. Okay, the biggest side is 14. That should be across from the biggest angle. That's F. Okay, that's the biggest. So that means the medium side should be across from the medium angle. Okay, so the medium side is 10, so that's going to be across from the medium angle D. Alright, listing them from least to greatest. So E, D, F. Or if I wanted to get fancy, because this is least to greatest, and E is less than D, which is less than F, would be another way to do it. Alright, that is it for the lesson. I hope you absorbed that information. Remember, the bottom line, really I said right at the beginning, If I want to find the total degrees inside of a shape, I use the formula n minus 2 times 180. If I want to find one angle, then I simply do the total degrees divided by the number of sides, which would be n minus 2 times 180 divided by n. If I'm hunting for the number of sides, I could just put this in my calculator and go through the list. Finally, please remember that exterior angles always add up to 360. So I will not do n minus 2 times 180. Exterior angles, I will add them all up and set them equal to 360 instead of using n minus 2 times 180 to find the total. Here endeth the lesson.